Here's a recap of the chain rule from your textbook. So, we use chain rule when we want to differentiate composite functions. So we'll go over what a composite function is. So you need to be able to recognize what a composite function is. So that's part of the difficulty, deciding when we need to use the chain rule. So let's do an example. Let's take this function h of x, which is the square root of 17 minus x cubed. Now, if we wanted to say compute h of 2, what many of you would do is first compute 17 minus 2 cubed, which of course is 17 minus 8, or 9. And then after you compute 17 minus 2 cubed, which is 9, you would then take the square root of 9, which is 3. So that consisted of two steps. We would say that h of 2 is 3. We had these two steps. The first step was to compute 17 minus x cubed, and the second step was to do the square root of x part. Okay, so if we think of h of x minus 17x cubed, we're going to think of this as there being an inside function and an outside function. The inside function being the first step, and the outside function being the second step. So h of x is a composite function. We do this in two steps. Our g of x here, our inside function, is 17 minus x cubed, and the square root function, square root of x, is our outside function. Okay, it's what we do second. If we were going to compose these two functions now, f of g of x, we should get back to h of x, square root of 17 minus x cubed. A different way to think about this is to say, I'm going to take u to be 17 minus x cubed. That's our inner function. So the inner function sometimes is easier to figure out because it's the step we would do first. We would do 17 minus x cubed first. So that's our inner function. And then if we take h of x, which is the square root of 17 minus x cubed, and replace 17 minus x cubed with u, what we've just defined to be our inner function, replace 17 minus x cubed with u, we get square root of u, which is our outer function. Okay, that might be a little bit simpler way to think about our outer function. Okay, now we've talked about looking at a composite function and determining what's our inner function and what's our outside function. Now let's go ahead and state the chain rule. So if f and g are differentiable functions, then the derivative of f of g of x is equal to f prime of g of x, the derivative of the outer function, and we leave the inside function alone, times the derivative of the inside function. Sometimes you'll also see this written as dy dx equals dy du times du dx. This one can sometimes be easier to remember because if you pretend like these are ordinary fractions, there's a du on the bottom and a du in the numerator, and so it almost looks like they cancel. They don't really cancel, but it might be a little bit familiar for you. Now, how do these two relate? They actually say the same thing. dy du, that's the derivative of the entire function with respect to u. That's our derivative of the outside function with respect to u, which is our g of x. And then du dx is the derivative of the inside function. It's like g prime of x. So we will work on using these a lot. We'll have lots and lots of examples, and that's because the chain rule is such an important and can sometimes be difficult concept. We'll be working on this for a few days and have lots of video examples.